Alright, so 2.3 is solving multi-step equations. So all we're going to be doing is doing what we did yesterday, except instead of taking one step, you have to do two steps. It's not that hard. All it is instead of doing one thing, we're going to do two things. Just one extra step. Alright? So, your homework is page 93 and 94, 1 through 10 all, and 30 through 39 all. Notice it's all, not odd, it's all of them. Alright? Now, let's take a look at 2-3. Alright? In the past, like I said, we solved one-step equations. Fantastic. Now, though, we're going to solve equations involving more than one operation, meaning more than one step, more than just adding and subtracting or multiplying and dividing. Right? Also, we're going to solve equations involving consecutive integers. Ooh, that's something different, and we'll go over that. Why? They use the Tour de France as one. It's just explaining that we can solve things that takes more than one step. We're going to take a look at that right over here. All right? It says solve multi-step equations. Notice it's in yellow right here. Why? Because I think that's important. Now, multi-step equation, they're saying is an equation that takes more than one step to solve for the variable. Meaning we're going to do more than one thing. Right? Same thing though, we want to get x and we want it to be single. It wants to be single. So take a look at this example right here. Solve each equation, check your solution. Well, here we go. When I see this one, if I zoom in even more, x wants to be by itself. So I'm going to put a little box around the numbers that are in the way. I should write maybe a little bit smaller. No, that's fine. Okay? So what ends up happening is two things now have to get out of the way. I have to do the opposite for two things. The opposite of subtracting 4 would be to add 4. That is why you see right here plus 4. Right? They're saying, well, 8, I want to be alone. 4, get out of here. So they move the 4, but if I add 4, I have to add 4 on the other side. Remember, it has to be even. So when they do that, these cancel. They make 0. So I'm left with 11x. And then 29 plus 4 is 33. But x is still not by itself. This guy won't go. So we have to say, what is 11 doing to the x? Well, a number next to a variable means multiply. A number next to a variable means multiply. So if I'm multiplying 11, I'm going to have to divide by 11 to get rid of it. Because opposite of multiplying, divide. Now when I do that, why? Well, look. 11 divided by 11 is technically 1x. Or just x. So they just put x. But whatever I do to one side, I have to do the other. So 33 divided by 11 is x equals 3. And now I'm done. If I wanted to check it, I plug it back in. 11 times 3 minus 4 equals 29. We have to see if that's true. 33 minus 4 equals 29. 29 equals 29. I am A-okay. Alright? So, I have it correct. Notice though the reason it's a multi-step is instead of just doing one, how many steps did we do? We had 1 and we had 2. 2 steps. Now look at this one. Look at B. It's still a two-step equation, but one of them we have to do first. Now, the A wants to be single. It's like, I'm single, I want to mingle. I don't want these people with me. So, I'm going to circle the ones that are in the way. And now all I have to do is the opposite, okay, or the inverse of what they're doing to the A. Well, the 7 is adding, it's positive 7, A plus 7, but I have to get rid of the division first. It's a fraction. And it's like, I have to get rid of it first. Now, if they were multiplying, I could just flip it, but I can't. What ends up happening here is I need to get rid of this. Whenever the variable is with the plus over all of it, it becomes different. It becomes 2 steps. So here's what I'm going to do. The opposite of dividing by 8 equals multiply by 8. So what do? We're going to multiply by 8 to not just one side, to both sides. Now, why am I doing that? Well, if we take a look right here, 8 times a plus 7 over 8 is going to cancel. Here's why. Remember, the whole reason we do the opposite is to get rid of, to cancel things out. 8 over 1 times a plus 7 over 8, what's going to happen is these are going to cancel out because I end up getting 8 divided by 8, which is 1. And so the 8's gone and this 8's gone. And all I'm left with now is the top. But if I multiplied by 8 on one side, I have to multiply by 8 on this side right here. So 8 times 5 is 40. Now, all I'm left with is with the top. And that's why I have a plus 7 equals 40. That's one step. But now I have to do another step because it's a multi-step. The 7 is not leaving. The 7 is being stubborn. It's not getting the hint that, yo man, I don't want to talk to you anymore. Like, you got to go. So the opposite of plus 7 is minus 7. You got it. Minus 7. So 7 minus 7 cancels us to a point. A is now by itself. 40 minus 7 is 33. I get A is by itself and it equals 33. If I wanted to check it, watch. 33 plus 7 over 8 equals 5. I get 40 over 8 equals 5. 5 equals 5. And it is a true statement. Alright, so I am finished. It's a multi-step. All it is I'm doing two. It's two people trying to get in the way of the variable instead of one. Alright? Next, I have some guided practice. Here's the guided practice. So what I want you to do is I want you to try the guided practice out. Okay? I want you to try the guided practice out. When you're finished with the guided practice, I want you to raise your hand and I will come by and check your answer. If I'm checking another person's answer, go ahead and pause the video and just wait till I'm done so I could check your answer. Alright? What I would do right now is pause the video. And then I will put the answer on, I would pause the video, work it out on a piece of paper, and then start it up again. So that way the video isn't going. So pause the video, try these 3 problems. Let's see if you can get the answer. I will come by and check your work. Alright? Move forward. Raise your hand. Make sure you raise your hand. I'll come by and check. If I'm working with someone, just pause the video, keep it paused, and then I will go by and I will check it when I'm free. Okay? It doesn't take long. Now, example number 2 is a little trickier, right? This is now real world example. If I take a look right here, they're saying how can I use this in real life? How can I set up something in real life? And we really do. We honestly, I swear, I promise you, we really do use this in real life all the time, but we do it more logical. We don't set up the variables or anything. We do that kind of in our head, to be honest. But I'm going to read this. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price? I'm going to underline that. Original price of the skis. Write an equation for the problem, then solve the equation. So our whole goal is to find the original price of the skis. Well, we're back to kind of the last section where words, variable, equation. 2/3, what? Is 2/3 times P. Why? Well, it says right here that the water skis are 2/3 of the original price. So 2/3 times P. Well, what's P stand for? P stands for the original price because it's 2/3 times the original price. Or I could say, you could put a different variable, but why did they choose P? They chose P because price, P. They could have put O for original price. It just depends what you want. Now notice they also have minus 25. Where did that come from? Well, remember, he ended up using a $25 gift certificate. So after you buy something, what happens? If your total is $30 and then you use a gift card of $10, well, you're going to only pay what? $20 because the gift card was applied. So that's where this part comes into play. They're saying, hey, don't forget I used a gift card so it's even cheaper. So now I have an equation, and it's right here, and I have to solve it. So here we go. They put now 2/3 times P minus 25 equals 115. How do I know it's equal to 15? Well, it says right here that what? The total cost before taxes is 115. They said after everything for his skis, he paid $115. So equals 115. Now, remember, look at, I have a fraction. We did this last time. I have a fraction next to a variable. How do I get rid of that? Well, let's remind you, if I have 2/3 P and I want it to get rid of, I'm going to multiply it by the opposite, by the flipped one. This, to get rid of this, I multiply it by the reciprocal. I flip it and multiply, and then they are gone. So, here we go. What's going to end up happening, notice that they want to get rid of the constant first. Yesterday, they said to get rid of the constant first, and you should always get rid of the one that's not with the variable, which is 25. So the opposite of negative 25 is what? You got it right. It's positive 25. But if I do that on one side, I do it to the other. And now those are gone. Okay? And I end up getting 140. Why? Because 115 plus 25 equals 140. All right? Now look, I have this. It's like, this is so nasty. I don't want to do it. Remember, when you have 2/3 times the variable, all you have to do to get rid of it is multiply it by the flipped version. So that way this is canceled. This is canceled. And I'm left with P, but now the hard part. This part right here is where everybody gets scared. They're like, oh my gosh, what do I do? Remember, for fractions, it's technically 3/2 times 140 over 1. There's always a 1. And for fractions, you multiply straight across. So 3 times 140. Oh man, how am I going to do that? Well, if you have a calculator, you can do it. I'm doing it right here by hand, and it's 420. So I'm going to get 420 divided by 2 times 1 is 2. What's 420 divided by 2? Ooh, 420. I know some of you are going to be laughing because I'm saying 420. Oh, and I wrote it in green. Uh-oh. Don't act silly, all right? 420 divided by 2 is 210. And that's what we get. So we found out that the price of the skis was $210, but after he got a discount, okay, of 33%, and his gift card, he only had to pay $115. You had to pay $115 for $210 skis. All right? Now notice right here, we have 2 practice problems. So, what's going to end up happening is, I'm going to want you to do this part right here. Guided practice example 2, there's 2A and 2B. All I'm asking for you to do is I want you to try 2A or try 2B, at least during the video. And raise your hand and show me your answer. So pause the video right here, look at your book at Guided Practice Example 2, 2A and 2B, and I want you to do at least one of them. Raise your hand so I could see your answer when you are done. All right? If you have questions so I can help you. Okay? Okay. Now, for solving consecutive integers, it's a little bit different. All right? It's not the same. It's a little different, but first, what is consecutive integers? Well, consecutive integers means one after another, meaning straight across. Consecutive is one after another. So if I say consecutive integers or consecutive anything, it's one after another. For example, 1, 2, 3, 4, 5, 6, 7, 8. Those are all consecutive, one perfectly after another. If I were to say consecutive even, well, consecutive even is 2, 4, 6, 8. It's one after another. But if I say 2, 6, 10, well, those are not. These are not consecutive. Why? Because I'm still missing. 4 should have been there. 8. I'm skipping. Consecutive means you don't skip. Consecutive means one after another. Okay? So, what ends up happening here is we're going to be solving for consecutive. And they tell you something. They give you it. This chart right here is my cheat sheet. It's very important. And it's going to tell me when I read these numbers, I use this equation. So, when you see consecutive, your symbols are going to be n plus 1, n plus 2, and so on and so forth. It just depends how many you need. Right here, I would need 3. These are all if I need 3. Because 1, 2, 3. Also, for the word consecutive integers, look at, they're the same. Consecutive even and consecutive odd are the same. It's just a different order. Even is 2, 4, 6, 8, 10, 12, so on. Odd is 1, 3, 5, 7, 9, 11, 13, and so on. So how are we going to do this? Well, first off, look at this highlighted word, number theory. What is that? It says it's the study of numbers and relationships between them. So we do that every day. When we're studying math, we're always studying number theory. We're saying, how do things work together? What is their relationship like? What is numbers? Why? What are numbers doing? What are they doing? All right. So that is what number theory. They want to let you know that because in Algebra 1 is when we start doing number theory, when we start actually analyzing it more in depth. So let's look at example number 3. Uh-oh, the last example. Uh-oh. So number theory, it says write an equation for the following problem, then solve the equation and answer the problem. So we need to find 3 consecutive odd integers with the sum of negative 51. Well, 3 consecutive odd, let's see, consecutive odd, so n plus 2, and n plus 4. That's what I'm going to use. Tells me right there. So we're going to let n be the first one. We're going to let n plus 2 be the second one, plus n plus 3 be the third one, because I needed 1, 2, 3. Why? It says 3 right here, consecutive odd. Okay? So now what do they have to equal? Well, negative 51. That's what it says right there. So what do? Look, they put it right there. And now what ends up happening here is if you see they combine n plus n plus n is 3n. 2 plus 4 is 6 equals negative 51. Now, oh my gosh, what do we have? Uh-oh, what do we have, everybody? What do we have? We have a two-step equation. Look, the n wants to be by itself. Who is in the way? The 3 is in the way. The 6 is in the way. So what am I going to do? The opposite of positive 6, subtract 6. Whatever I do to one side, do to the other. That's going to cancel the 6's. Negative 51 and a negative 6 is negative 57. Negative 51 plus a negative 6, negative 57. Now, if I'm multiplying by 3, remember a number next to a letter or variable is multiplying. Opposite, divide by 3. Cross out. I get n equals negative 19. I did a multi-step equation, but different. And now we know, watch this. If I go negative 19, what else? Negative 19, what do I have to do? Negative 19 plus 2, negative 17. Negative 19 plus 4, where am I getting that from? From this right here, look. Equals negative 15. And let's add those all up. Negative 19 plus negative 17 equals negative 31 plus negative 15 equals, ooh, did I make a mistake? Ooh, I added wrong. Oh my gosh. Yeah, I should have been like, that's not right. This is negative 36 plus negative 15 equals negative 51. Wow. So I got it. These 3 are consecutive odd integers that add up to negative 51. Did I accomplish what I needed to accomplish? Yes, I did. I just needed what? 3 consecutive odd integers that add up to negative 51. And I did find that. All right? This is how you set up. This is your cheat sheet. Okay? Now, I believe also I do have a guided practice for that one, example 3, it's find 3 consecutive integers with a sum of 21. Now 3 consecutive integers, ooh, what is that? Look at that cheat sheet. Look at that cheat sheet right here. 3 consecutive integers, ooh, ooh, ooh. 3 consecutive integers. Where are you at? I lost you. Where are you? It's right here. Consecutive integers. Look at what we're going to use. N plus 1, n plus 2. How do you think I'm going to set it up? How do you think? Oh, we're going to give you a hint. N plus 1 plus n plus 2. N plus 2 equals what? They tell us. I think it's 21. All right? So do that guided practice. Pause it. Do that guided practice. Pause it. Raise your hand and show me the answer to this one. What is this answer? All right? After that, after you show me, we are done. You can do your homework. Your homework's right here. Ask me questions. Do not wait. Your homework's right here. Get to work.